Thank you for joining me when I take you through the journey we have had from something cozy and comfortable to something scary. I won't be super technical in this presentation. I mean, if you want to learn Rust, there are much better teachers than I am. So with that said, let's begin. My name is Camilo. I work at 24HR. We do everything from IoT development, system development to WordPress sites. And I was the CTO until 1.5 months ago when I became the CEO. But I like to call myself programmerande VD. I love to code. I've been coding my whole life, and I will continue to do so. And I learned to code back when these two guys were the hottest guys on the planet. I got my first computer back in '87, this beautiful Atari 800 XL, with which I learned to code Atari Basic. And since that, I programmed some other languages as well. Lots of HTML, lots of C#, PHP, a little Java, lots of ActionScript when ActionScript and Flash was something. And of course, lots and lots of JavaScript. And it was back in around 2010 that a friend of mine, a developer who I respect very much, told me about this crazy thing that you could use to run JavaScript on the server. And it was quite intriguing. I mean, this was in the beginning of the Node journey. And I was excited, not everyone. Some people on the internet were not as excited as I am. They were angry as they are on the internet sometimes. But for me, it represented almost like a revelation. It was like the new way of doing things. You had Apache with PHP, and you had IIS and ASP.NET, and that was like the old way of doing things, and this was new. You could write a HTTP server in like 5 rows of code, and if you had a bug, it would crash completely, and then you had to take care of that. But it was fun, more responsibility, more things to do. So it felt like being a pioneer. And from that day on, back in 2010, we began to use Node as our go-to tech on the back end. And a couple of years later, when React came along, it was like a full circle, because now you could use JavaScript on the front end with JavaScript on the back end, and you became a full-stack developer quite easy, at least easier than before. And with SSR, you could reuse the code, so it was like isomorphic code for real. So this became like this perfect pink little fluffy bubble of things we could use, our tool set to create whatever was thrown at Node. It wasn't the perfect language, it was good enough for most things. And it became a universal tool for us. But as you know, as all universal tools, they work well in some situations, but in others not. And we began to see the cracks in our bubble. Especially when you begin to use Kubernetes, for example, and you need all the resources that exist, and Node takes a lot of memory, and it isn't super performant. So we began to look at alternatives, not to replace Node, but as a complement to Node. And maybe the most obvious tool to use would have been Go. It's easier to learn. It's fast enough, and I don't mean this as any offense to Go lovers out here, but for me, myself, at that point, felt a little like melonmilk, like, okay, it will take me some places, but if I want to have something to complement Node with, I want to have something that takes me as far as possible with that. And there are many other options, of course. You could have Sig or Gleam or Mojo or whatever. And if you're using those, you're probably being more of a pioneer today than Rust. Rust is quite old, actually. But Rust had these things that were interesting. So you have the performance part, that's what Rust is known for, and the memory safety part, super good to have. But it has also this rumor of being super difficult to learn. And maybe what intrigued me the most was that I read that Rust does things a little different than some other languages. And those two last things were the most interesting part for me. If you have something that's challenging, the rewards are often bigger. So this presentation will be about the journey we took, the journey I took and our company took. Some projects we found along the way that were good to use to learn and to see the results. And also what 1 year of transition has given us, because it was around 1 year, maybe 1 year and 2 months from the second I began to test out Rust to where we are today. So we are not done, but we're getting there. So you have decided that you want to use Rust. You, of course, begin to look at some code. You look at some examples, you watch some YouTube videos. And from a Node developer's perspective, the first thing I thought, and many of my colleagues as well, was that the code is super ugly. It has so many strange things. It feels just bad. If you look at some examples, you have some Pascal case. That's not strange, but you have some ticks as well. Why? Well, of course. You have some ampersand or some ticks, and then you have some return function that doesn't say return. It doesn't have a semicolon. And you have some camel snake case, because why not just mix everything up? And when you are there, you can put some double colons as well. And let's put some exclamation marks, because why not? But you accept this. This is like the first entry. You can't give up here. You begin to code some more, and you begin to try to compile things. And the first thing you will see is that the compiler will constantly complain about what you write. It will become your enemy. It fights with you all the time. And it's super frustrating, because you just want to reuse some variable. But that's how it is. You accept it, and you continue. So you say, OK, let's code some more. I need a string. Well, I'll just write a string. And no, it's not that easy. In Rust, you have 9 different kind of strings. And you can choose from whatever you want here. And I have to say that I mostly use the first 2 and the last 2 here. But I think this is interesting, because this represents the difference between Node and JavaScript in general and Rust. Meaning that in JavaScript, everything, if you want a string, is just a string. Everything else is taken care for you. Here you have to decide. You have to decide because you have more control. And by letting go of this control in Node and JavaScript, you pay some price. The price of the garbage collector and the performance and the memory, etc. And here you need to decide what you want to use, because you need to have more control. So you accept this as well, of course. You continue. And your Node brain continues to compare this, of course, all the time. So you write some Express.js hello world example just for the sake of trying, and you get like 15,000 requests a second, and just on your computer, or my colleague's computer, mine is not as fast as his. And then you do exactly the same thing in Rust, just to compare it, and you get this figure instead, which feels much better. So it's 15 times faster, just some short example. And I know this hello world isn't representative of real world examples, but still, it's good. And I really like this kind of figures, big figures like this. You continue, and you see other quirks. So you don't have to have return every time. You can have 2 functions. They both return things, but some of them don't need return. And by the way, the first one is the most correct one. The compiler will complain otherwise. But it's just like that. And there are so many other things in Rust that feel so alien and so strange compared to what you're used to. So you have no exceptions. You can't throw an error in Rust. There is a result type that will give you either the value you expect or an error type, which means that the compiler will enforce to check for both values, both situations. So exceptions are not treated as something different. The same goes with null and undefined. There are no null and undefined in Rust. You have an option value. You have to return the value itself or none, and you have to check. If you don't check for both, the compiler won't compile, basically. You have lifetimes, which are maybe the most complicated part, and traits, which I will mention in a little while. But some time goes, you continue to test, and after a little while, you begin to think that, oh, whoa, what is this? I'm beginning to like it. I'm beginning to see why some things are as they are. I'm beginning to like it a little. Of course, you still complain. You have a big enemy still complaining about your code all the time. But you just move on, and you found the power of enums, for example, which are quite different than what you're used to in Node, and even in TypeScript, of course, because enums in Rust can have values. And this might not seem like a big thing, but they give you the ability to code differently. Because there are some things you can't do in other languages when you don't have these tools. And they can even have functions as well. So enums are like a completely different thing suddenly, even if it might not seem so. And you see that Crates.io has a huge amount of modules, so most of the things you will need are already there because Rust, again, is stable, has been there for a while. And suddenly you begin to see that you like the syntax. It isn't as strange and alien as it was in the beginning. It's not that bad. You understand why there is so much syntax, because there are so many things you have to declare and say, so you need more different kind of characters to actually tell what the code should do. But you go back to TypeScript because that's your daily driver. You have lots of other projects running in TypeScript, and you feel constrained. It's like claustrophobic almost. And you just have the feeling that you want to write everything in Rust. All the things that you have in your company, all client things, let's write everything in Rust. Let's do even the front end in Rust, because why not do it when you can? And I skipped some of my things, so let's just move on here. Yes, so you realize that you miss Rust. Again, you want to rewrite everything, and you want to do all the front end in Rust. And it's possible because there are, of course, frameworks to do everything in Rust as well, but it's not the best thing to do, I think, but you could, of course, do it. But you take a break, you take some steps back, and you come to the obvious realization that, of course, Rust is not for everyone. Because in the world of JavaScript, again, it's easy to be a full-stack developer, easier at least. You know that there is a big difference between server-side code and front-end code, but the lines are more blurry. You can use the knowledge you have on the back-end to code some front-end and vice versa. And with all the meta frameworks out there, like Next.js, Solid Start, etc., the lines are even more blurry. So it's almost like you don't know what you're writing. Are you writing some server-side code or front-end code? You don't know that. With Rust, the difference is super obvious. And this means that if you have lots of developers that are used to writing JavaScript on both parts, you will have a spectrum of different feelings about this. So some of your developers will maybe not hate you, but look at you very strangely. Some of them will be nervous. You might have junior developers that have begun to code JavaScript from day one, or even senior developers that only have coded JavaScript. And you suddenly introduce something that seems so complicated that it scares them, and that's natural, and you have to accept that as well. So you need to have a plan, and I think there are like a couple of target groups in this plan. ChatGPT generated some very similar 30-mail something versions of these people. You have your CEOs, and the CEOs will be, I think, at least mostly interested in what is the cost of the transition if we say we go from one part to the other, and how difficult would it be to actually hire people? Is it easy to find Rust developers or not? You have project managers that might be more interested in saying, okay, can we keep the deliveries? Can we meet the deadlines, etc.? How is the quality assurance? And you have developers, which is a very broad group. Again, you have senior developers that might have tried lots of different languages, and some of them that only have written things in JavaScript, only in a good sense also. But everything here begins with you, because if you're here, hopefully you're super enthusiastic about this. So you begin to look at what you can do in production, because all the tests you have done so far are fun, but you know how it is in production. You learn the real things. So you try to find a good candidate. You look at your stack, you look at everything you have done. Maybe you have the luxury of having lots of microservices that can be isolated, so you pick one of them. And for us, it was, we had a microservice that we used to process images. So basically, our clients can upload images in whatever size they want, whatever format they want. They don't need to worry about that. And we will resize them or crop them when they are requested. Not when they are uploaded, when they're requested. And we make sure that they are processed in the best format possible. If their browser allows a VIF, let's take that. If there's transparency, let's take WebP, etc. So basically what the microservice does is download some binary data from either a URL, S3, or Azure Storage, resize it, crop it, analyze it, upload it again so we don't have to do everything again, and then serve it. And all these things have been done before by us in a Node version with Sharp that is pretty competent. I think Sharp has some C bindings behind it. But the problem with Sharp is that after a while, we could see that the memory usage went up to 1.5 gigabytes of memory. And it kept that. And again, in Kubernetes, you fight for all the memory you have, so you want to reduce this as much as possible. So it was like a perfect fit for us. And it's also a perfect fit when you begin to do something in production, because you begin to challenge how your brain thinks. So for me, it was with traits in Rust. So Rust isn't object-oriented. Rust doesn't have inheritance. It has traits instead. And I don't like classes in JavaScript. I don't use them as much, but still, my brain looks a little like this. I'm very good at taking a problem and converting it to Node. That's what I do. But converting it to Rust took me a while. It was like the restructuring my brain to think differently, because Rust is different. And you can't just apply what you know directly. So my brain worked more like, I take the problem, I convert it in my mind to Node, and then I try to figure out how Rust works. And that's like a 3-step process, which was very frustrating. I wasn't as fast as I wanted. But after a while, I got past that. It's something you need to do. It's very good for your brain to think like that. And we could see that when we deployed this to production, we had 20% of the memory consumption on the same service after a while. And we have a much, much faster startup time of the process itself, which means that if you are scaling things, it's super efficient. It processes the images much faster, and generally speaking, you could say that Node normally, or Rust normally, is about 4 to 50% faster than Rust. That's just a generalization. But what this means is that it will cost less to run, and it will take less energy to run. And that means at a microscopic level, of course, that it's better for the planet as well, because you are not using as many resources. And all these last slides I've shown you right now are like the perfect slides to show to a CEO or a manager, because that's always a good trigger. So you have convinced some managers at least, and you need to take the next step. You need to convince your skeptic developers, because again, they still think it's strange and scary. And one way of doing that is to try to demystify it, try to make it a little less scary. And one way of doing that is to show them a completely unscientific graph that I created myself, where you have JavaScript somewhere and you have Rust somewhere. And you can say that, okay, if you know some TypeScript, you are further up the learning curve. I would think that you're actually a little further up than that. You have generics and things like that. If you know C#, it's even easier, maybe even further than that. And there are some things that are much harder than Rust. So if you know Vim, for example, and Rust is nothing, so you know that that's easy at least. And you can show them examples. Here's an example of a Rust HTTP server. And there are many strange things, of course, but the basics of it, you have a route and you have a handler. That's almost the same as Node. So it's not that difficult. Some things are very familiar. And it's important to show these things because that makes it easier to understand. So what I did was I tried to find a project that could involve as many as possible at the company. And we had this, we call it a panic board. I think it was inspired by Panic, the company, in 2012 when we created the first version of this. This is the third. So it's basically just a Node server and React front end that we use to show something on our TV in the kitchen. It has information like, okay, who has the breakfast next time, which album do we need to play, and who has the birthday, etc. And it's made so that any developer can take any module and write it themselves without the need to care about the rest. You can really just do whatever you need to do. 7 months ago, around something like that, we got into this, and you don't need to read the details, but basically it didn't build anymore. And it didn't build anymore because I think there was some React thing, and it's a Docker image, so I tried to upgrade one part, and it led to the next upgrade and to the next, and you all know upgrade hell. So I thought, okay, should I continue and rewrite this in a more modern Node and React, or should I do a new one, which is what I did. And the new one, it uses solid JS instead of React. I prefer that over React. And of course, some Rust backend. But I made sure to take care of all the plumbing, all the things, all the mechanics around it, so that whenever someone wanted to code some Rust, they just needed to worry about their thing, nothing else, making it easier for them to get into Rust, to try it out, to demystify it. So they just have to implement these two traits. The details aren't that important. But if they do this, then their module will work. And nowadays, we have a new version. There are a couple of blocks that aren't filled. That's because we haven't translated them. But the point here is that with these kind of things, I have quickly gotten 6 to 7 of our developers, we are 15 developers, so it's quite a big number, to actually try out Rust without fearing it as much as they might have done before. So, where are we now? We have a couple of projects in production, which have saved lots of memory and CPU. We have a couple of projects, internal projects, the panic board being one of them, a couple of CLI tools, and other things that we can try out using Rust. There are over 60% of our developers that actually have coded Rust. I won't say that everyone loves it, but at least they have tried it. They don't fear it as much as they did before. And maybe most importantly, every project is considered in Rust. So when we are about to create to estimate a project, for example, we see if it's isolated enough, we estimate it in Node, and we try to estimate in Rust. And of course, estimating something that you don't know that much about is hard, and it's a guess, but it's guessing all the time, even with Node as well. And if the numbers aren't too far away, or if the project itself is small enough, then we take the risk and try to do it in Rust instead, because it's like the perfect way of learning. And we, of course, take into account that some things will take some more time, and we might not be able to bill all the hours, but that's okay. That's part of being a company that tries to learn all the time, which I think everyone here would agree with. And we have today, I think, maybe there is one project in Rust being done for a client, and we have 2 on our way. And all this in 1 year's time. And again, 1 year from beginning to look at it to where we are right now, which it feels good for me, at least. And we don't have any haters anymore. Again, I think we have maybe people that are skeptical. A little. I think the difference between front-end and back-end becomes so obvious. So the people that don't like back-end will really don't want to touch Rust. But that's okay. You have to accept that as well. So some takeaways. I think I'm very early. I talked too fast compared to every time I tried this out before. But there are some takeaways here. I think everything here begins with you. If you're enthusiastic enough to be here, your enthusiasm will be contagious. That's almost the most important part of this. You need to share your progress. You need to share both the wins and the frustration. I think both parts are as important when you try to show other people what you are trying to do. You need to try to find small projects in production as soon as possible to make sure that you not only test or, I don't know, proof of concept things, because the only risk is that it will take a little more time. That's it. It's not like you're trying something that will break. It will be possible in Rust, and it will be good. And you need to try to involve as many people as you can. It's much more fun to be able to talk to some other developers and figure out how to solve things than doing it by yourself. And if you can't do it by yourself, if you can't find people in the beginning, try to find projects where you can share your progress. And most importantly, I think that this is the most important part, is that you shouldn't be afraid of it, because I don't think that Rust is that difficult. It's very different, but it's not difficult. It requires you to program your brain, and that's always good to do anyway. It doesn't matter if you use Rust afterwards, but it requires you to restructure it, to think differently, and the rewards are huge. And if you're a good Node developer or any other language, the same concepts, at least, will give you the performance boost just by using Rust. Of course, if you're a bad Node developer, you will probably write Rust code that is slow as well. But that's true of all languages. But if you're good enough, then you will get the bonus of having the performance boost and memory boost. So don't be afraid. Just take the leap, write some Rust, and have fun. Thank you. I have one bonus slide. I don't know if this is true. I tried to find any community about Rust in southern Sweden. I couldn't find anything. Maybe there is one that I missed. If anyone knows one of them, let me know. If not, we don't know any, then I'm interested in maybe starting something at least, because I think the interest for us is there. There's just not that much organized interest. So please let me know afterwards if you know or if you want to be part of it. Thank you very much. Any questions? Yes. Yes. We tried to find it, and we couldn't find anything, but that doesn't mean that it wasn't our fault. We just didn't do more research.